a scatter plot is just a graph that represents the two sets of data. So the scatter plot is the graph that represents the bivariate data. Okay. Clustering occurs when you have, and you're going to be able, it's going to be a lot easier to see in a scatter plot than when you see the list of numbers, because what you're going to see is some dots that are kind of clumped together. Okay, so these would just be data values occurring close together. Data values occurring close together. Okay, and then an outlier, we're going to use what my formal definition is a data point with a value that is very different from the other data points. A data point with a value that is very different. So maybe by very different it means very much higher, or maybe it means very much lower. Okay, so I tried to make it obvious then that these are going to have some of these properties that I mentioned above. So just from looking, what is the outlier? Yeah. Okay, so good. I'm glad you wrote the ordered pair, because these are x comma y's, and it looks like it is 6 comma 75. Do you see that? So right over here. Doesn't that look very different than the other points? Okay. Good. Then do you see, I know that this you might not have done before, do you see anything that might look like clustering to you? Can you tell me one spot? Okay, so it looks like there is clustering. This is a day. Okay, so I'm going to say clustering on day 1. And it also looks to me like maybe one other day. Okay, so we see that we have some points that are occurring close together. All right, and so really what this probably is, I didn't put a title on my graph, but this is probably some kind of a florist shop, and how many days of experience, so days you spent working, and then how many bouquets they can make in a day. Probably as they get more experience, they get faster at making them, which is why we generally see the data go up. But it looks like they have different employees, right? Okay, because they have different, how many people? 1, 2, 3, 4. 4 people on day 1 made that many bouquets. And then it starts to get spread out. Okay. All right, so then the last thing we're going to talk about is association or correlation. Has anybody heard the term correlation before? Okay. Correlation really is how close the points are together, okay? And so if something has strong association or correlation, what the data points do is they cluster in a predictable pattern. The data points cluster in a predictable pattern. I think I put, yeah, good. All right, so mostly for us in this lesson, we're going to look at ones that cluster kind of in a line shape, and so the closer they get together in the form of a line, we would say the stronger they are. Weak association or correlation means that there's still some relationship, but the data points cluster a little bit more loosely. So the data points cluster, they're not as tight together. Loosely in a pattern that is less predictable. Oops, I'll move this down for you. So now's the fun part. Now we get to draw some dots. Okay. So we're going to just, these do not have to be perfect, but we're going to just draw some pictures of what it means to be strong. And we have strong positive. Strong positive means going right and up. Strong negative means going down. And then we have no correlation, and no correlation looks like just a bunch of dots. So here we go. Let's draw some pictures. So a picture of strong positive correlation, what I'm going to do is I'm going to make some points, and they're not going to be perfectly in the line, but I'm going to put them really close, okay? Really, really, really close. And I know, I just like to add some in there, okay? If you were to kind of circle those points, like draw a circle around them, do you see how that they're going to the right and going up? Could I draw a line through all of them? Not one line, okay? But we would call this strong positive correlation because it looks like a general pattern of going up and to the right. Okay, weak positive. Would you now make these, instead of being close together, let's spread them out a little bit, but we're going to still make them go in the positive direction. So maybe something more like that. Okay, are they still going in general up and to the right? Yeah. But do you see how they're a little bit more loosely clustered than the first set? If I were to draw an oval around those, my oval would have to be a little bit wider. No association. No association means there's none. Would just draw a bunch of points all over. No pattern. Okay. Okay, so what do you think the difference then is between strong positive and strong negative? Yeah, like a line with a negative slope. So we're going to make a close pattern again, but now we're going to start our pattern up here, and we're going to make them go down, but still real close together. All right, so now let's make some weak negative association or correlation. And so we're going to start our points at the top, and we're going to make them go generally down, but we're going to make them more loosely clustered in that downward pattern. So most of the time that we're going to spend over the next week and a half or so is actually then drawing lines and writing equations for lines. And the equation part is not new. That's from last semester. But there is other patterns. So what I want to just show you is a strong linear pattern means that these are all linear, these four. Let's draw a strong linear pattern. We'll do it up. Okay. Strong linear pattern. I happen to do a strong positive linear correlation. And I'm going to draw some points for you, and you can tell me if you recognize this pattern. Ooh, I heard a couple people. I heard somebody say parabola and somebody say quadratic, right? Do you see how it's U-shaped? It's possible in other courses that you will see quadratic or even exponential data. Exponential kind of curves up like that. So that's nonlinear though, because it's not a line. Okay, still a pattern, but it's nonlinear. So that exists, that is out there. But you are right. If I was using an adjective, the adjective is quadratic because it describes the pattern. The noun would be parabola because parabola is the actual graph. You didn't think you were going to get any grammar in here, huh? I had to brush up on my grammar because Charlie was doing grammar. Difference between adverbs and adjectives and nouns. Okay, so quadratic would be the descriptor of that kind of data. All right.